the November 2021, grade 12, question 9. In the diagram, PQRS is a cyclic quadrilateral. PS is produced to W. TR and TS are tangents to the circle at R and S respectively. T is equals to 78 degrees and Q is equals to 93 degrees. So RT is equals to ST because those are tangents that are drawn from a common point. And then this whole angle should be equals to Q because it is an exterior angle of a cyclic quad. 9.1. Give a reason why ST is equals to TR. Tangents drawn from a common point. (9.2.1) In triangle STR, because they are looking for S2, I know that R2 should be equals to S2 because of opposite sides equals to angles. So R2 plus S2 plus T should be equals to 180 degrees, and this is the sum of angles of a triangle. And then R2 we said is equals to S2. So here I'm going to have 2S2 plus 78. This is 180 degrees. So S2 is equals to 180 minus 78 over 2. That's a 51 degrees. 9.2.2. They are looking for S3. S2 plus S3 is equals to Q. And this is because of the exterior angle of a cyclic quad. S2 is 51. S3 plus 93. S3 is equals to 93 minus 51. That's 42 degrees. Question 10. In the diagram, BE and CD are diameters of a circle having center M. Chord AE is drawn to cut CD at F and AD is perpendicular to CD. Let X be equals to C. Okay. CD is a diameter. Angle A1 plus A2 must be 90 degrees because CD is a diameter. This is true for A2 plus A3, given that BE is a diameter. And then AF is equals to FE because of the line that is drawn from the circle, the center of a circle, and it's perpendicular to the chord. (10.1) Give a reason why AF is equals to FE. This is because of the line from center pep to chord. So it bisects the chord. 10.2. Determine, giving reasons, the size of M1 in terms of x. I'm looking for M1. Let's look at the arc CE. The arc CE subtends M1 at the center. It also subtends A1 at the circumference. This means that M1 is 2 times A1 because it is the angle at the center, and it must be 2 times the angle at the circumference. Looking at triangle, in triangle ACF, A1 plus C plus AFC is equals to 180 degrees, the sum of angles of a triangle. A1 should be equals to 180 degrees minus C, which is x, minus AFC, which is 90. This is 90 degrees minus x. And then we said M1 is equals to 2 times A1. The angle at the center is equals to 2 times the angle at circumference. So M1 is 180 degrees minus 2x. 10.3. Prove, giving reasons, that AD is a tangent to the circle passing through ACF. ACF, so I have a circle there. And then I need to prove that AD is a tangent to the circle. If I can prove that A2 is equals to x, because then I would have the tangent and a chord. So that would be the tan-chord theorem. If I can prove that A2 is equals to x, then AD will be a tangent to that circle. This angle right here is 2 times A2 because it is the angle that is at the center, and then A2 is the angle that is at the circumference, and they are both subtended by arc ED. M1 plus EMD should be equals to 180 degrees, and this is simply because they are angles on a straight line. M1, that's 180 degrees, minus 2x plus EMD. EMD is equals to 2x. And then EMD should be equals to 2 times A2. The angle at the center is equals to 2 times the angle at the circumference. This is 2x. That's 2A2. Therefore, A2 is equals to x. This means that A2 is equals to C, which is equals to x. Therefore, AD is a tangent. And this is because of the converse of the tan-chord. 10.4. CF is 6 units and AB is 24 units. 24. Calculate, giving reasons, the length of AE. They are looking for this length. Okay. AF is equals to FE from here. And then we know that EM is equals to MP because EM is a radius. From E to M, that's a radius. From P to M, that's also a radius. So notice how the line FM joins what? The midpoints of the sides of triangle EBE. So I'm going to have triangle EB, it's ABE, and then I have that line, which is FM, and then this side is equals to that, this side is equals to that, and I have a 24 there. And then now I can apply the midpoint theorem. And then I'm going to say AB is equals to half of FM. And this is because of the midpoint theorem. So FM is equals to 12 units. This was supposed to be 2 times. So that this is 24, 2 FM, and then I can divide both sides by 2. Yeah. Okay. And then now I have this whole length because this is a 6 and that is a 12. So the radius should be equals to 18 units. That's the radius of the circle. Now I am going to focus on this. I have a 90 there. BAE is equals to 90 degrees. Angle in semi-circle. I have a 24 there. And since MP is 18 and ME is 18 as well, BE should be equals to 36. Now I can apply the theorem of Pythagoras. And I would say AE squared plus AB squared is equals to BE squared. Pythagoras. AE, that's what I'm looking for. BE, that's 36 squared minus 24 squared. Squared minus 24 squared. This is 26.83 units. Question 11.1 is a proof. And then we're gonna do 11.2. In the diagram, PK is a tangent to the circle at K. Chord LS is produced to P. N and M are points on KP, such KP and SP respectively, such that MN is parallel to SK. Chord KS and LN intersect at T. Okay, so KP is a tangent. So it means that this angle is equals to S1 because of the tan chord theorem. Okay. Then the whole of this angle is equals to the whole of that because of the tan chord theorem. 11.2.1 A. Prove that K4 is equals to NML. So it is equals to that angle. Okay, so we have parallel lines here. So we have an F. This angle should be equals to that. So NML is equals to S1. And this is because of corresponding angles, given that MN is parallel to SK. And then I know that K4 is also equals to S1 because of the tan chord. This means that K4 is equals to NML because they are both equals to S1. B. Prove that KLMN so the whole of that must be a cyclic quad. Well, since this angle is equals to that angle, then KLMN is a cyclic quad. You will say K4 is equals to NML. Therefore, KLMN is a cyclic quad. And this is because the exterior angle of a cyclic quad is equal to the interior opposite angle. 11.2.2. Prove giving reasons that triangle LKN is similar to triangle KSM. In triangle LKN and triangle KSM. So the way in which you are given these two triangles, it means that L is equals to K, and then K is equals to S, and then N is equals to M. So you need to prove them in that order. L must be equals to K, K in this one must be equals to the S, and N must be equals to M. Okay. Remember that KLMN is a cyclic quad. So it means that this angle is equals to N3. Let me just show you where this is coming from. So we have chord LN. So it subtends what? N3. It also subtends what? M3. So we have angles on the same segment. So this is a line, this is a line. It subtends these two angles. So they are angles on the same segment. So we will say M3 is equals to N3 because they are angles on same. Sorry about that, I got distracted. So we said M3 is equals to M3. Okay, because they are angles on the same segment. Okay. So now we just need to prove one last angle, and then the triangles will be similar. Okay. Well, L1 is equals to M2. So it's for the same reason, because I'm going to have that base, and then I have M2 subtended, and then I also have L1 subtended. So this angle and L1 are angles on the same segment. Okay. But M2 is equals to K2 because of alternating angles. This line is parallel to that, so this angle should be equals to that. So it means that M2 is equals to K2, alternating angles, because NM is parallel to SK. Therefore, L1 must be equals to K2. So now we have proven two angles, so the third angle is implied. Therefore, so we have K2 being equals to L1, and then we have N3 being equals to M3. So it means that S2 in this triangle should be equals to excuse me, NKL. NKL, that angle of triangle. Therefore, triangle LKN is similar to triangle KSM. 11.2.3. If LK is equals to 12 units, LK is equals to 12, and then 3KN is equals to 4SM. Okay, determine the length of KS. Excuse me. So we are going to use the proof there. We will say LKN, triangle LKN is similar to triangle KSM. Let me just fix that. That is an N. LK goes with KS, and then KN goes with SM. So we'll say LK over KS is equals to KN over SM. And then I'm going to use the first and the last letter, which is equals to Ln over Km. And then now Lk, I do have Kn over Sm. So I do have these two, and I'm looking for Ks. Lk over Ks is equals to Kn over Sm. And this is because of similar triangles. 4Kn is equals to 4Sm. This is a 3. So Kn is on top, Kn over Sm. This should be equals to 4 over 3. Lk, that's a 12, Ks, and this is 4 over 3. Ks is equals to 12 times 3 divided by 4. So that's a 9. 9 units. 11.2.4. It is further given that NL is 16. NL. So that whole length, that's a 16. And then LS is a 13. LS is a 13. And KN is 8 units, okay? Determine with reasons the length of LT. So I'm going to use this triangle, because there I can apply the proportionality theorem. You can see that this line is parallel to that one, so we can use the proportionality theorem. In triangle LNM, I'm looking for the length of LT, and then I'm given ln. So it's LT over ln, and then LT corresponds with LS, ln goes with LM. This is because of a line parallel to one side of triangle. That's TS parallel to NM. LT, that's what I'm searching for. LN I do have, LS I do have, LM. I do not know what the length of LM is. However, I know that 4K, it's 3KN is equals to 4SM. And then I'm given that the length of KN is 8. So this is 4SM. So this means that SM is equals to 6 units. So now I have a 6 there. So I can add the 13 with the 6 to get a 19. LT, that's what I'm looking for. LN is a 16. LS, LS is 13 over LM, that's a 19. So LT is equals to 16 times 13 over 19. So I'm getting 10.95 units.